Good day. Today I will discuss my answer in Activity 7 in Electricity and Magnetism. In number 1, in what ways are electric and magnetic fields similar? Both electric and magnetic fields are the consequence of the attraction and repulsion of electric charges. However, a magnetic effect is caused by moving electric charges, while an electric field is caused by stationary charges. Number 2, a positive charge is moving vertically upward when it enters a magnetic field directed to the north. In what direction is the force on the charge? The answer is a positive charge is moving vertically upwards when it enters a region of magnetic field directed towards north. That is the direction of the force on charge. Using this, force equals to Q times velocity times b equation. And right hand rule, we find that the force acts in west direction. In number 3, a stream of protons is moving parallel to a stream of electrons. Do the streams tend to come together or to move apart? The answer is if they have large speeds, then they will move apart because the magnetic interaction is more repulsive than electrostatic attraction. If they have small speeds, they will come closer to each other as electrostatic attraction between them is stronger than the magnetic repulsion between them. Number 4, the ends of a bar magnets are traditionally called its poles, with the end that tends to point north called the North Pole and the end that tends to point south called the South Pole. Like poles of nearby magnets repel each other and unlike poles attract. Explaining this behavior in terms of the interaction of current loops. The answer is magnets poles. The area of the magnetic field where the magnet's power is the strongest is called the magnetic pulse. If a magnet is hung so that it is free to turn, it will turn in the north or south direction. The end that faces the north is called the north-seeking pole or north pole of the magnet. In number 5, a charged particle moving perpendicular to an uniform magnetic field allows or follows a circular path. Find the radius of the circle. In getting the answer, we have a formula or a figure. A force of a magnetic and force of a centripetal. The radius is directly proportional to the particle's momentum and inversely proportional to its charge Q and the magnetic field B. In number 6, a cable 5 meters apart above the ground carries a current of 100 ampere from east to west. Find the direction and magnetic of the magnetic field on the ground directly beneath the cable. Neglect the Earth's magnetic field. The answer in this part is using a formula, we get the answer which is 4 times 10 raised to negative 6t. In number 7, two parallel wires 10 cm apart carry currents in the same direction of 8 ampere. What is the magnetic field halfway between them? By the given data, we get the answer through the use of formula, and the magnetic field between them is equal to 6.4 times 10 raised to negative 5. Number 8, a 100-turn flat circular coil has a radius of 5 cm. Find the magnetic field at the center of the coil when the current is 4 ampere. We also use a formula in this problem. We get the answer which is 5.03 times 10 raised to negative 3. And number 9, a solenoid 0.2 meter long has 1,000 turns of a wire and is oriented with its axis parallel to the Earth's magnetic field at a place where the latter is 2.5 times 10 raised to 5 negative 5t. So what should the current in the solenoid be in order that its field exactly cancel the Earth's field inside the solenoid? So in this number, we cannot get the answer without a formula. So answer is 5 meter ampere. And also, all that I compute is shown in my file attached there. So that's all. And thank you.